Hey there friends, what is up? Chris Ewing back with another video. Yesterday we had some debate on Facebook about the right settings for welding dissimilar thickness materials, something as thick as 1 inch to something as thin as 1/8 of an inch. Now I'm here to tell you that there's more than one way to skin a cat. So people that are calling me crazy for 24 volts, 400 inches per minute, I'm not crazy. My mom had me tested. So let's get into it. Okay, this is how we'll be conducting our science experiment today. We have here is some 1 inch thick plate. We have here some 1/8 plate. I will do the 4 individual lap welds, and heck, maybe I'll flip it over and do the fillet weld on the backside too to see how it would work out in more of a T-joint configuration. We have our 17/8 180, 2300, 21.5, and 250, and 24 and 400. So let's see how it works out. All right, so if I remember correctly, the machine in question was a Miller 252. I don't have one of those. What I do have closest would be the Multimatic 255. So that's what we're going to start with. And we're going to go to the lowest recommended setting first, and we'll work our way up from there. So lowest recommended setting, I see 17.8 and 180 from Mr. Chris Wintella. Let's see how that works out. All right, weld number 1 is going to be the 17/8 and 180 inches per minute. I'm going to try and be as scientific about this as possible, and I'm going to drag all of my welds. So let's give this one a shot. Now this is solidly in the short circuit, and these are settings that I would most likely use if I was welding 1/8 inch to 1/8 inch. It's going to be awfully cold, I think, for a mixed material thickness weld like this. I'm doing the best I can by focusing more heat into the thicker plate and then just kind of blending it into the top edge of that 1/8 inch material. I have a feeling this will also be the longest weld as far as time is concerned. I mean, it's okay. I would call that just a little bit cold. Doesn't blend into that thicker plate very well. Is it attached? Sure. But the question is, for how long? All right, next up, let's visit Damon Switzer's settings at 20 volts and 300 inches per minute. Boom. All right, next up. You can already tell it's blending a whole lot better into that 1 inch plate. It's moving a whole lot faster as well. So that ripple pattern is a whole lot closer together because that weld is a whole lot hotter. So we can see when it's colder, we have a more defined ripple pattern because that weld is cooling a little bit more between each movement of the wrist here. This one burned a lot hotter. That ripple pattern's a lot closer together. It does fuse into that 1 inch plate better than the last weld we did, but I think we can keep going. Let's try the next one. All right, Mr. Paulie Brown, you sided with the internet on this one. You looked at me like I'm crazy. Let's see what your settings are. 21.5 and 250 inches per minute. So up on the voltage and down on the wire speed from the last one. I think these settings will work out okay. Let's give it a shot. This is solidly in that short circuit. We can actually hear and see that the wire is hitting and burning back and hitting and burning back over and over again. I don't think it's bad. I think I would come up on the wire speed a little bit for this increased voltage here. All right, so we can see, looks very similar to our 20 volts, 300 inch per minute. I do think I got a little bit of extra buildup on that one actually. And we can see there's a lot more spatter and dust all over that one. Like I said, I would have come up with the wire speed with that increase in voltage. It seemed like it was burning back a little too rapidly, and that would be fixed with increased wire speed. Last up, my own personal setting, 24 volts and 400 inches per minute. Now, I mentioned on that Facebook post that if we're using 75-25 gas, it's not going to take us into a true spray transfer. However, it's going to function close to a spray transfer. If you do want to get into those spray transfers, you have to have, I believe it's 80% argon or higher, 82% argon, something like that. On these machines, I usually run a 90-10. That will allow me to do the spray transfer, and these machines are capable of pulsed MIG. So you're right. In Paulie's response, it is difficult to control spray transfer if you go out of position at all. It's for flat and horizontal fillet welds only and flat groove welds only. You don't want to try that outside of those parameters. Now, if you need to get that spray transfer in vertical, overhead, anything like that, pulsed MIG welding is the way to go. But that's for another video. 24 volts and 400 inches per minute. Let's see how it goes. All right, moment of truth. Am I crazy insane or insane crazy? Let's find out. Okay, so I'd be willing to bet that that was the fastest of any of them. And I would imagine the deepest penetrating as well. So are those factors? Absolutely. Still got a little bit of that dust on there. A little bit less spatter than on the previous recommendations. Let's see if we can get a little closer view. Blends really nice at the toe. Fused that top piece in there. Moved a lot faster. All right, now let me start by saying the purpose of this video is not to prove anybody wrong, rather to prove that everybody is kind of right. We say there's more than one way to skin a cat. There's more than one way to put the weld down, more than one setting. Does it meet what the WPS says? Does it meet what the code requirements are? Does it meet what the job requirements are? Those are the factors. And then from there, when you gain some experience, you can start to decide, well, I can set it this fast, get a good deep penetrating weld, and get that job done X% faster. Or if I need to slow it down so that I can do a little bit more manipulation, whatever needs to happen. That first weld, 17.8 volts, I think that's a little cold. I don't know if I trust that one. The other three all look like proficient welds to me. Now again, this is a visual inspection. I'd have to do a cut and etch to actually see the level of penetration into these things. And let's be honest, over a Facebook comment, we're not going to get that into it. I'm going to flip it over. I'm going to weld the other side out using those same settings for each spot. So this is 21.5 and 250. This is the 24 and 400. We'll see how the T-joints look. But until next time, hope this helps.